कोशिश करेंगे इसको ले जाएं, और हो सकता है मैं चेंज भी कर लूँ, मसला नहीं है, मैं देखूंगा। इट डिपेंड्स के वैसे मेरा इरादा था पहले मैं ऑसिलेशन स्टार्ट करवा लेता। मैं पूछता हूँ सर से, दोबारा डिस्कस करता हूँ। तो ऑसिलेशन की बजाय हमारा, क्योंकि इलेक्ट्रिक फील्ड, इलेक्ट्रिक, ये सारे एक साथ मिलते जुलते टॉपिक्स हैं, तो ये हो जाएंगे तो इट वुड बी फाइन। ठीक है, होपफुली। यस, आई थिंक नो वन एल्स इज गोइंग टू जॉइन। यस, हंजला आ गए हो? हंजला कैसे हो बेटा, मुझे बताओ ना कि मैं आ गया हूँ, ताकि मैं फिर स्टार्ट करवा सकूँ। फुल स्क्रीन, ठीक है, ओके जी। एवरीथिंग क्लियर टिल दिस पॉइंट? वी हैव स्टार्टेड, आई मीन वी आर डन विद द इलेक्ट्रोमैग्नेटिक फोर्सेस ऑन अ वायर। और आज हम लोग डिस्कस करेंगे द टॉपिक we are going to discuss, that is the forces, the magnetic force on a charged particle. Okay, magnetic force, खुदा कैसी हो बेटे? ओके, सो मैग्नेटिक फोर्स, खुदा आपको आवाज आ रही है मेरी? ओके ओके, गॉट इट, ओके, गुड। सो मैग्नेटिक फोर्स ऑन अ चार्ज particle. Okay, charged particle. First of all, we will talk about that if we have a charged particle and that charged particle is placed in a magnetic field, right? Then that charged particle must be in a wire. तो वायर के अंदर आपके पास जो चार्ज पार्टिकल होगा, that charge particle will be considered as a simply a part of wire. So in that wire, let's say if we have a wire of copper, let's say it's a copper wire, and there is a charge, that charge is moving from one point to another point in this copper wire. Let's say this is the total length of this wire is L. From this point to this point, the length is L. Okay, and there is a charge particle at this point. This is your point A, and this charge particle is Q, and this charge particle is moving to point B in time T. The time traveled to a time required to travel through this length is T. So actually, what did I do? That I have connected a wire uh, to this main segment of the wire. Here is the positive terminal or a negative terminal. So what will happen? The charge will flow from position point A to point B. I mean to say that there will be a current flowing through this. So this is the current I, and the main thing what I have not yet indicated, that is the magnetic field. So here is the magnetic field. Now if the magnetic field is into the page, this is a region of uniform magnetic field. Here is the region of uniform magnetic field. So what do you expect, that will there be any force on this wire or not? This way, this is a wire, this is a magnetic field, right? What do you think? This is basically yani the magnetic field is into the page, the current is from your right to left. Let me call it point X, and let me call it point Y. Sorry, I have called the point A and point B. So current is from A to B. So that means that there will be a force. And what will be the direction of that force? That force will be downward. Is it? Do you agree? Now the problem is, actually my target is in yani this time my target is not this force. My target is actually this single electron which is traveling through this wire from point A to point B, and it moves with a constant velocity and it reaches to this point. So every time that uh, current, that charge will experience a force in this direction, yani the force to move through this point, right? And the force I have shown to you, but when we calculate that force, we simplify the force, that the force acting on this charged particle was sorry, acting on this wire was bi L sine theta. And the wire is at 90 degree, at 90 degrees, so that force is equals to BIL, because theta is equals to 90 degree and sine 90 goes to 1. Now one more step ahead, if I say that this entire discussion helps me out if I just replace the current in terms of charge, so I will say that this force is equals to B into Q divided by T into L, right? And this force is equals to B into Q into L divided by T. So the distance traveled per unit time is what? That is your velocity. Do you agree? Is it? Is it clear to everyone? So distance traveled by the object per unit time is the velocity. So I can simply say that this F is equal to BQ into velocity. So now this situation, in this situation, you got a new equation that the force on a charge which is placed in a magnetic field, it is equals to Q V B sine theta. Got it? This is the equation which will help you out to understand the concept. Got it? Is it clear to everyone? QVB sine theta. So, beta, the QVB sine theta means here the angle will be theta is the angle between which two components? The magnetic flux density P, okay, and velocity of the charge particle and velocity of the charge particle. So, are you getting my point? Is it clear to all? So that is basically the angle theta. So this is how we can find that the force on a charge which is in the wire, that can be calculated in this way. But now moving forward, I have to calculate the force on a free charge particle. That was not a free charge particle. That particle was into the feed, into the wire. So force on a free charge particle, free charged particle. So how to find that force? That force is, if I simply consider a particle, and that force on that particle will be, uh, that force will be applied in such a way that the particle will start moving in a circular path, right? So I will just write a short note here. Okay, when a force acts on a particle, and when a particle enters in a magnetic field perpendicular to the magnetic field, then what will happen? It experiences a force, and that force is directly proportional to yani the velocity of that charged particle, definitely, as I shown to you, and directly proportional to the magnetic field strength. That is why it was QVB. But the direction is important. I will talk about the direction. So uh, here just a small note that when a charged particle, free charge particle enters a uniform magnetic field, uniform magnetic field normal to the field, or normally it experiences a force, right? It experiences a force, and is that force tends the particle to move in a circular path. That force tends or compels the particle to move in a circular path, okay, to move in a circular path. The most important thing. When the particle moves in a circular path, it means that that force, what we are talking about, that force behaves just like a centripetal force, isn't it? Am I right? Yani, this tells us that the force which I am talking about, that force behaves just like the centripetal force. So that centripetal force is basically, responsible to bring the charge particle in a circular path. Right? Are you getting my point? Yes. So that force acts as a centripetal force. So entire physics is here that, for example, if I have a uniform magnetic field, and in that uniform magnetic field there is a region of uniform magnetic field, instead of drawing all these crosses, let's say this is a region of uniform magnetic field, and the magnetic field is into the page, and a charged particle which is entering in the in this uniform magnetic field with velocity v. This is a charged particle, right? It is a positive charged particle. It is entering in the uniform magnetic field with velocity v. So at this point, here I will just write one thing for you, that use sorry, for positive charge, whatever the positive charge you have, alpha particle is positive, any sort of positive charge particle, what will you do? Use left hand three finger rule, right? And for negative charge, what will you do? You will use right hand three finger rule. That is basically a sort of, you people know about this all, but I just wrote it just for a reference. So a positive charge is entering this way. Its v is in this direction, b is into the page, so both are normal to each other. So due to that, do you know what will happen? The charge will not continue its motion in the forward direction, rather the charge will be drifted a little bit, and the charge will be drifted a little bit in this direction, because force is applied in the upward direction. Here I can figure out the direction of the force. This is the direction of the force. So that force will tend the particle to drift from its original path, or from its actual direction of motion. So this is the new velocity of the charged particle, right? This is the new velocity of the charged particle. Now what will happen? The charged particle will experience a force in this direction, perpendicular to this, and due to that, the particle, instead of moving this way, the particle will tend to move in this direction. So in this way, if I continuously draw the direction of the forces, if you see that the particle will not continue its direction straight, rather it will continue its path in the curved or in a circular path. So overall, if I just tell you that what will be the direction of motion of this particle, if I draw the magnetic field in this way and the motion of the charged particle. So overall, what is what is the motion of this charged particle? The charged particle has a curved path or a circular motion. You got my point? This is the direction of the charged particle. Is it? So due to this all setup, I can simply figure out some points here, and those points are, for example, I will take just several positions for my charge particle, not all around the circle. So, if the charge particle is moving in this circular path, then the force acting on this charge particle is basically having the direction perpendicular to the direction of motion of this charged particle. This is in this way, right? Here it is in this direction. This is the force which acts towards the center of the circular path. Okay, are you getting my point? So here, this is that force what I am talking about. This is your gravitational force, sorry, this is your magnetic force, and this is the velocity of the charged particle, this is the velocity of the charged particle, and so on. So this all mechanism will be now discussed in this way, that if I have a charged particle and that charged particle is moving in a circular path, then Fc, that is coming right from where? Fb, magnetic force, right? Fc is centripetal force and Fb is magnetic force. So if I just draw, or sorry, if I just plug in these values for magnetic force and gravitational, sorry, centripetal force, then Fc will be equals to Fb. What was Fb for a charged particle? That was equals to QVB sine theta. Is it? Are you people agreed? Okay. So that is equals to Fc is equals to mv square divided by r, and that is equals to QVB sine theta. Now the angle formed here is basically equal to what? What is the angle formed? Yes. Can anybody tell me? What was the angle? Angle was 90 degree, na? Is it?
Yes, sir.
Yes. So angle was 90 degrees. So for that 90-degree angle, if you simply say that now the equation will shrink in this way, mv squared divided by r, that will be equals to qvb. Right from this equation, or right from this, I will get number of derivations asked in your past papers, in your exams. Right? There are so many derivations. For example, some of the derivations I will discuss with you right here, and the remaining, definitely when you will practice the questions, then you will know about these all. So first of all, from here you can calculate the momentum of the charged particle. Okay, momentum of charged particle. So if I say that right from this equation, mv square divided by r, that is equals to qvb, then this one v will be cut by v, and remaining part of the equation is mv is equals to rbq. It is very resembling with the word barbecue, so you people will never forget this, inshallah, that rbq is equals to mv. Basically this is the momentum of the charge particle, right? What is that? This is the momentum of the charge particle. Any confusion at this point? The next part what you want to calculate, yani, it's simply momentum of the charged particle is directly proportional to r, b and v. But the most important thing from here, that is the deflection of the, sorry, the charge to mass ratio of the particle, right? What is the most important from all? Charge to mass ratio. Charge to mass ratio of particle. If you want to find the charge to mass ratio of a particle, the same equation will help you out. This one. For example, how? You know, here you have written mv is equals to rbq, and from this one, you charge to mass ratio is what? Charge to mass, q by m. So from here, q will be written as it is, m will be divided with q, and on the other side v will be divided by r times b. So this is the equation which tells you about the charge to mass ratio. But this is not the final destination. The charge to mass ratio means something. How we can find the charge to mass ratio? For example, if there are several charged particles which are entering in a region of uniform magnetic field, and that region of uniform magnetic field is basically uh, that region of uniform magnetic field is in such a way that these charged particles are deflected in different directions, then how or what is the factor which is making this thing possible? For example, one charged particle is deflecting in this direction or at this point, the second charged particle is deflecting here, third charged particle is deflecting here. So do you think that all of these charged particles, they are making different traces, isn't it? Yeah, these there are three charged particles. They all are entering with velocity v, and they all are entering in the uniform magnetic field or magnetic flux density, and these all are the positive charges. So why they are deflecting in different direction? So this deflection or this deviation from their main path or the original path, that is a very, important point, that yes, this was their path, but now they have been deflected in this way. Okay, are you getting my point or not? So for example, let me call their names A, B, and C. So what do you think, which charge particle has the maximum deflection? Deviation, other than that, deviation or deflection?
A.
Yes. So deflection is inversely proportional to the radius of the circle or circular path. Yani, if I say or if I see from here, that tells me that A will make smaller circle, isn't it? A is making a shorter circle, na? So radius of or curvature of A is smaller than curvature of B, and that is smaller than curvature of C. But that shows that deviation or deflection of A is greater than deflection or deviation of B, and that is greater than deflection or deviation of C. Is this point clear to everyone?
Yes.
So, from this equation, I will just make a simple setup for you where I have written that V divided by RB, that is equals to Q by M. I will just keep this Q by M as it is for my requirement. I will just separate this 1 upon R here. 1 upon R is equals to this Q by M into B divided by V. Is this clear to everyone? Are you getting my point? Hello, everyone.
Yes, sir.
Okay. So, if I say that here, instead of writing this 1 upon R, the deflection of the charged particle is Q by M into B divided by V. So, isn't it wrong? Is it correct now? So, which charged particle will have more deflection? So, from here, deflection is directly proportional to charge to mass ratio of the particles if they have entered in same B and they have same V. Are you getting my point? So, for example, if in a electric field, one is alpha particle and one is your proton, right? Although they have different charge and different mass, But for example, if there is an alpha particle and there is a, sorry, there is a positron and there is a proton, both have same charge, both are positively charged particles. One is positron. Positron is basically, this is a positron, and let's say that blue one is a proton. It is also entering with the same speed. So here I will let you know that is a specific charge or charge to mass ratio of these particles is studied in this way. Charge to mass ratio is equals to total charge, that is 1.6 into 10 raised power minus 19 coulomb, divided by mass of a positron is, yani this is charge to mass ratio of a proton. Wait, both are carrying p, so I will write in this way: positron, right? So that is, positron is an electron, na? It is 9.02 into 10 raised power minus 31 kg. So yes, what is the charge to mass ratio? This is a constant number, it cannot be changed. Yes, yes. Meanwhile, you people can also now charge.
Sir, I got the answer. It's 1.77 times 10
Uh-huh.
power 11.
1.77 into 10 raised power plus 11
Yes, positive 11.
coulomb per kg. Coulomb per kg. Now talk about this proton. Proton. What about the proton? That is, for proton, you have the same charge, 1.6 into 10 raised power minus 19 coulomb, divided by its mass is 1.66 into 10 raised power minus 27 kg. Yes. What is the number? 9 point.
9.6 into 10 power, my, I think 7. Positive 7, yes.
Positive 7 coulomb per kg. So did you notice that, which, okay, according to this calculation, which charged particle will have more deflection, positron or proton? Yes, come on, come on. You people can make it. Question is, which particle will have more deflection? Charge to mass ratio of
Proton, sir.
proton or positron?
Proton.
Okay, that is greater than charge to mass ratio of proton. So the deflection of positron and deflection of proton. I'm considering that. Okay, now move back to the diagram. Did you see that the deflection is directly proportional to charge to mass ratio? Isn't it? Are you getting my point?
Yes.
So that is why your positron will be deflected more than that of your proton. So this is how you are able to segregate these particles. For example, there is a stream of particles, and from that stream of the particles, we are having two different deflections. It means that the particle which is deflecting more, its properties are different, and the particle which is deflecting less, its properties are different. So the blue one, it is deflected more. So that is my positron. You got it? And this one, that black one, is my proton. Is it clear to everyone? From these calculations, I have just concluded that. Now, in the same way, as I told you, so here I will say that is directly proportional. Is it clear to everyone? Now, there is another calculation which is asked to you, most probably, that deflection is directly proportional to B, right? If a charged particle is entering in a stronger magnetic field, then its deflection will be more. But if a charged particle is entering in a magnetic field with more velocity, its deflection will be less. Is this clear also? Mhm. If a particle has more velocity, it will have more kinetic energy, and definitely, if it has more kinetic energy, it would be difficult to bend that charged particle quickly or rapidly. Is it clear? So, I was talking about this all. Now, if I talked about the kinetic energy, so we can calculate the kinetic energy of the particle. Kinetic energies of particle, right? And the kinetic energy of the particle is again a very simple thing to understand, that we can find out the kinetic energy. I will write one note here, that is an important note. So it will be written here that this charge to mass ratio is used to identify the particles, right? Identify the particles. If you have different particles in the stream of particles, then they can be identified by charge to mass ratio. Okay, and this is also called specific charge. What do we call that? This is also called specific charge. Is it clear to everyone? Okay, so kinetic energy. So as I told you, that equation, that it was mv was equals to rbq. So how can I make this for kinetic energy, as my kinetic energy of the charged particle is equals to 1 by 2 m v square. Thank you. Mv square. Then this kinetic energy, Ali, this velocity from here, I will plug in the value of velocity. Velocity is equals to rbq divided by m, isn't it? Just plug it over here. That is m into rbq divided by m whole square. Here it will be written simply m. So it is m into r square b square q square divided by 2m square. So m will be cancelled by this 1m, and your equation will be formed as r square b square q square divided by 2m. So this links, you know, this links with the momentum of the charged particle as well, because the kinetic energy is equals to rbq whole square divided by 2m. So that gives me a new relation of kinetic energy. That was equal to momentum of the charged particle. So that was momentum ka square divided by 2m. If you remember, this was an equation in your AS level. that the kinetic energy is related to momentum. This equation. Is this clear to everyone? So you can calculate anything which is related to this. I have some more, mm, derivations which can be asked to you, but mainly whatever the derivation is involved here, for all derivations, key, what is key rule? Put fc equals to fb. This is the same key rule I have given you for fg is equals to fb, is it? सॉरी एफ जी इज इक्वल टू एफ सी, तो वहां से आपको ये चीजें मिल गई थी. क्लियर है? शुड आई मूव टू नेक्स्ट?
Yes, sir.
ओके, नाउ there is the application area, and in the application area I will talk about the velocity selector. Okay, velocity selector. Velocity selector is actually the application of this charged particle, or the particles accelerator or something like that. The velocity selector has a principle, and this is asked to you for 4 marks. Okay, then I will talk about the working and all that stuff. Principle of velocity selector. First of all, I must tell you that velocity selector, it is used to determine the velocity of charged particles. Okay, velocity of charged particles. That is why it is called velocity selector. Second point, it consists of two fields. Electric field and magnetic field are placed normal to each other. So here this is an induction of new thing. Electric and magnetic field must be normal to each other. Normal mean perpendicular to each other. Okay, this is asked to you for 4 marks. That is why I'm going to write the points. Fourth thing, that a charge particle entering entering normally a region, entering normally a region where electric field, I'm talking about electric field, not force, and magnetic field are normal to each other. Okay, magnetic field are normal to each other. The particle, I'm talking about the particle, experiences a force. The experience is two forces. Experiences two forces. What are those forces? Electric force and magnetic force. Is it? Is it clear to everyone? When electric force, this is Again, very important. I will not write electric field. I will write electric force. When electric force and magnetic force becomes equal and opposite to each other, electric force and magnetic force become equal and opposite to each other. We adjust them actually equal and opposite to each other. Then what do you expect or what will you observe? The charged particle moves undeviated. Okay? Are you getting my point? The charged particle moves undeviated. Now, the velocity of the charged particle, this all is to be written. Velocity of the charged particle is ratio of E to B, yani electric field strength to magnetic field strength. Mathematically, V is equals to E divided by B. Till this point, I have written this all. Now I will explain to you with the help of diagram. Let's say this is a positively charged plate, this is a negatively charged plate, and a charged particle which is entering through this, right? Let's say that charged particle was entering, that charged particle has entered in this zone, and at this point, the charged particle was experiencing a force. Now, let's say at this point, the charged particle has the force which is equal in equal and opposite in direction. Like, okay, first of all, let me draw the charges. This is a positive charge. Okay, there's a positive charge, yani this plate is connected with positively charged positive terminal of the battery. And what about the next other plate that is connected with negative terminal of the battery? So what will be the electric field, by the way? What will be the direction of electric field? From top to bottom. Is it? Everyone getting this point or not? This is the electric field. Okay. Okay. Now, if I say that what will be the magnetic field here, if sorry, wait, due to that, if this charge is positively charged particle, if this is a positively charged particle, what will be the electric force acting on this charged particle? That electric force will be downward. Do you agree? F
Yes.
electric will be downward. So to keep it in equilibrium, where should or what should be the direction of the magnetic force? Magnetic force should be upward. Is it? Are you getting my point? Where should be the magnetic force? Magnetic force should be upward. And when this is upward, at that time, I will simply say that now this force is that force is produced due to a magnetic field. अब आप देखो, where will you draw the crosses? Sorry, where what will be the direction of magnetic force, magnetic field? Into the page or out of the page? Mm-hmm. बेटा जी, if I want to have a magnetic force upward direction में, so where should I, what should be the direction of magnetic field on a positive charge particle which is moving or which has the velocity in this direction? Yes. Yes, come on. Black वाली force upward है. So should I not place the magnetic field into the page? Huh? Hello. If the magnetic field is into the page, तो मुझे ये बताइए कि what do you expect? That the charge will experience an upward force or not? है ना? Will it be? Yes. So here your electric field is downward. Magnetic field is B is into the page. Into the page. So you got these all points. Yani here I am showing the magnetic field by a cross. So that is why FB is upward, FE is downward. So in the same state, mathematically, here I'm going to draw the line which is basically the separation between these two parallel plates, and that separation, that separation is equal to D. And if I connect these plates with a voltage source which is basically here, okay, are you getting my point? What did I do? I just use a variable voltage source, due to which I can manage my uh, potential difference between the plates. So these two plates are at a potential difference V with respect to each other. Right? What is the potential difference between these two plates? Let's say this is the voltmeter that will show me the potential difference between these two plates. You got my point? Okay जी, is it clear to everyone? अब देखो, what did you suggest me mathematically? Mathematically, F electric is equals to F magnetic, and F electric is equals to what? Electric force is equals to electric field strength into charge of the charge particle, because you have studied this point, that electric field strength is equals to, as electric field strength is equals to electric force per unit charge, and for that purpose F is equals to E times Q. I have just used this background knowledge. Okay, am I right? Is equals to Q V B sine theta. Here, your Q and Q will be gone, and you got this point that here E is equals to V B, where V is the velocity. Yes, any question? And theta is equals to 90 degree, so that sine 90 goes to 1. So now from here my v velocity is equals to what? The ratio of electric field strength divided by ratio of electric field strength to the magnetic field strength. Is this very clear to everyone? You can simplify this variant in this way. E can be written as delta V divided by D, as I have delivered that to you in electric field topic, divided by B. So you can also write the velocity in terms of delta V, which is measurable with the help of potential voltmeter. Then D can be measured with the help of meter rod, and B can be measured with the help of a Hall's probe. So now you can measure the particle's velocity. Till this point, if you have any question, any doubt, anything to ask, I'm here. Yes. Anything you want to ask me? Nothing. Okay. See you
No,
then.
sir.
Any question? Yes, yes.
No, sir, no questions.
Yes, I will send you. I will. Yes, I will send you, inshallah. Okay.
Okay, sir,
Okay. Yes.
inshallah.
Okay. See you then. Is Lulu in the
Allah
class
Hafiz, sir.
and Yahya?
No. Yeah, he's not
None
in the
of them.
class.
Oh.
No.
Okay. Okay. So that was a bunk class. Anyhow. Okay. Let's see. Okay. See you inshallah. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz. जोया कुछ पूछना बेटा